Yeah, hi. Good evening, everyone. So today is Week-8 live coding session. So we will discuss some problems based on the Week-8 content. And Week-8, basically, we are learning this divide and conquer strategy to design the algorithms. Okay, design the code. So we will just check some related problems. So we have three problems basically. Okay, and I have already released on the Replit. If you have not opened this Replit team, just open the Replit team and refresh the page. So now you can see these three problems. Let me share my screen also. Yeah, Rashi.
Good evening, sir.
Yeah, good evening.
Sir, I wanted to ask that is OPP scheduled for everyone?
Yes.
Sir, but I haven't got any email on
So
from your side.
OPP is on next month, no? So I think 10th April approx. The date is 10th and 17th. Two dates are there.
Okay,
So you will get the message. So this 10th March is actually OPP1 happened. So they will send approx maybe 1 or 2 weeks before.
okay, sir.
Okay, just check your mail regularly. Hmm. So uh yeah. Let's go now. Hmm. So syllabus of the week. Sorry, this OPP is
Oh
till
yeah.
week 9. Okay, so week 1 to week 9 is the syllabus for OPP exam. And also we are changing the content a little bit in this term. So actually, after week 9, you will get one refresher week. So week 10, actually, there is no content will be released for week 10. After that, week 11 will be released. And week 12 is also there, but that content is actually not, that content is actually extra content now. So we have just shifted the week 10 content into the week 12. Okay. So that will be released as a extra content, and that will not be the part of syllabus for the end term. Okay. So if you want to learn, then you can watch the videos of that week, and you can also solve the practice questions. That is actually string matching algorithms, but that content is not the part of the syllabus this time. Okay, so after week 9, you will get one refresher week. So you can focus on that quiz exam, quiz 2 exam. Okay. Yeah. Okay, week 8. So let me open the first problem and let's see what type of problems. Uh, so for divide and conquer approach, you have already learned some base algorithms in the sorting algorithms. So that merge sort, quick sort, you have already learned where we are using the divide and conquer approach. It is not opening. So according to the divide and conquer approach, so there are two terms actually used for this strategy. One is divide and conquer, and one is divide and decrease. Okay, so divide and conquer means basically we break the problems into two sub problems, and similarly we break the problems continuously, and we solve each sub problem separately, and we merge the solution. Okay, so that is called divide and conquer approach. So in the same category, we have the another strategy, divide and decrease. So basically, if we are looking some data, if we are searching something, so in that case, we also divide the problems, but we remove the half of the problems every time. Okay, so we remove the half of the space for the searching, like this binary search you have already seen. So where we are also dividing, okay, we are dividing the problem size into the half size, and after that we are just solving, we are just checking the half part, and we are completely removing the next half part, other half part. So that is called basically divide and decrease. Where decrease means we are just decreasing the size after every dividation, and we are also solving the problem in the same manner. Okay, so that this searching type of problems are also comes in the same category, divide and conquer. And the another category, just like sorting algorithms, we have already seen this quick sort and merge sort, inversion pair, Week-8 content. We have seen this closest pair and closest pair of points, like this, these algorithms that we are using the divide and conquer approach. So we have the first column, basically. So we have total three problems today. So all are actually based on the divide and decrease approach. So we are looking some data and we are searching something, and every time we will just divide by the half of the problem size, and we will just remove that half. So basically, we can say that we are also figuring out the solution in log n time by this approach. Okay, and we have another problem, so where the complexity is different. So this is the first problem. uh, I hope you can figure out the logic for this. So what's the problem actually? Given a circularly sorted integer array, or this is actually list, we can see that find the total number of times the sort array is rotated. Okay, assume there are no duplicate in the array, and the rotation is in the clockwise direction. So here one example is given. Suppose this is a sorted list. Okay, 1, 2, 3, 4, 5. So when we rotate one time in the clockwise direction, so this 5 element will be removed from the end and it will be inserted at the beginning. So in this case, this is called as a one rotation. Okay. So after one rotation, we will get this type of list. So 5 will come at the first position, and then 1, 2, 3, 4. And again, if we rotate this list in the similar manner, so this last element 4 will be removed, and that will be shifted to the at the first place. So now 4, 5, 1, 2, 3 is the rotated list after two rotation. So in this manner, write a function find rotation count L that accept a sorted list L with n elements, which is circularly rotated k times. Okay, but we don't know what is the value of k. But this k value will be comes under this equal to 0 and greater and less than n. Okay, in between. So the function returns the value of k. Okay, and write the solution code of complexity log n for this. So here sample is also given. So you can see now if we see the actual sorted list, so sorted list will be start from 1. Okay, so minimum element this, and after that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is the actual sorted list, but it is rotated 3 times. Okay, so if we rotate this 3 times, so that we will get this rotated list. So output should become 3. This is easy. Okay, in the terms of if you can figure out the solution in order of n complexity, but how you can apply the approach of uh, like this divide and conquer, so you can get the solution in log n time for this.
No, looking at the first element, we cannot do this straight away because we will take n and then
Mhm.
see the
No,
first element.
so but this is not ensure
N
that the
minus first element and then add 1, it will come, right?
you are looking first element and then
N minus first element and add 1, it will be that many times, right? Not like that. Because it is sorted, you said.
this is sorted, but you are not sure. So this here all elements are given. So 1, 2, 3, 4, 5, 6. But these elements may be some
It can
value
be
may be set.
any can be from
Huh.
it can start from any number, you mean to say? It's
Yes.
not natural numbers.
Yeah, this is not the continuous number like this.
Okay.
Okay. So in that
Okay.
case, you cannot figure out.
Cannot do.
Hmm. So now think about this. If you are rotating this list, so how we can apply the this divide and conquer approach to figure out the number of rotations? You have already done similar type of problems in the week 2. So you can think what you can apply.
So can we use binary search here? Uh,
Same things we can try, because binary search is also one part of the divide and conquer things. But what you are trying to search here?
Basically, we have to find the minimum number in the list and the index of that minimum number. Uh,
Yes, correct. You got the correct logic.
but how
So,
to write in code? I was thinking.
huh. So now this problems become another problem. So now you need to find out the index of the minimum element. That index is also represent the same information, how many times this list is rotated.
Yeah, correct. Yeah, logic
Okay.
is correct.
Huh. So now the problem become find out the minimum element in the circularly rotated list, and this list is sorted. So you can also apply the same binary search concept here after little bit modification. So now think how you can apply the binary search logic here to find out the minimum element in the list. If you remember that we have done similar type of questions in the week 2 when we find out the peak element, the live coding sessions. Peak means maximum element in the list, but at that time that list was not circularly rotated. That was actually in the different format, but this time this is circularly rotated.
We can find the maximum and the minimum.
Hmm.
We need maximum and minimum, right, for the binary
You can either you can find
search.
maximum, then you have to add one index in this. Okay, so 0, 1, 2. Okay, so we are getting this 0, 1, 2 here. So this is the two
No,
index.
but in the binary search, we will be given with the element what we are going to search, right?
No,
With the list and the what we
I'm
are
not
going.
saying that
Here we don't know that.
I'm not saying that use the same binary search. I'm saying that use the similar type of approach binary search like this. Okay, so you have to little bit modify that.
That's it. I have to
Hmm.
think.
Here your target is also there. You need to find out the minimum element. Searching target is there.
Uh, Also, I lost my connection. If it is possible to brief up to
Okay,
this
okay.
which
That problem.
actually I joined now.
Okay, okay, fine. So this is the one problem. So actually here we have one input list, and this input list is actually rotated clockwise some number of times.
Mm-hmm.
Okay, so number of times means in one time if we rotate this list, so this is the one list. Okay, sorted list 1, 2, 3, 4, 5. You can see. So the element may be anything, so not in the continuous manner, but list is sorted. First element is smallest elements, and last element is the largest element.
Yes.
But if we rotate one time this list, so that means one element should be removed from the last and should insert it at the first place.
Mm.
So after one rotation, we will get this type of list. Okay, after second rotation, we will get this type of list. Okay, so two elements are now added in the before.
Mm-hmm.
So this type of input list is given to the function. Now you need to find out how many times it is rotated actually. Actual sorted list is rotated.
Okay. How
Okay.
many times? Yeah.
And that k value which is given here, so that k value k times it is rotated, but k value will becomes as in 0 to n minus 1,
Mm.
and your function should return this k value in the log n time.
Log n means
uh,
something
so
like
here
5.
this is
Mm.
we are asking the efficient approach here. Otherwise you can easily find out the solution. You can simply check where is the maximum element or where is the minimum element. After that you can simply just find out the difference between first index and the minimum element index, and you can figure out the count.
So why that is otherwise? Like उस अप्रोच में भी हम लॉगिन से कर सकते हैं ना, मिनिमम और मैक्सिमम को लॉगिन से फाइंड कर सकते हैं हम तो।
If you know, yeah, so same things I'm saying that now this is the one problem. So here one sample input is given. So how many times it is rotated? So answer is 3.
Yes, index
Now,
of minimum one.
so how we can figure out this answer for these problems?
Minimum one. Sir, since the list is sorted, so I think we can take decisions based on like divide, like binary
Huh.
search, what we did earlier.
Yes, divide and conquer things you can apply, and binary search, similar type of binary concept you can apply here. So, but what you are trying to search from binary search?
Actually, first I will go to the mid, and I will try if I can reject left or right space. So since suppose sir,
No, first thing, tell me what you are trying to search in this.
sir, I'm not actually I'm trying to find the minimum
Minimum,
number.
okay.
Yes.
Yes.
So suppose
So after getting the minimum, how you can return the answer?
the index of the minimum.
Yes, correct.
Hmm.
Okay, so that index of the minimum is representing the number of rotation. Yeah, correct. So yeah, now you can think about this approach. How you can find out the minimum element, minimum index,
So
minimum element index.
I think we can take decision like
But how to go about? Say for example, it is rotated. If it is 10 element, if it is rotated 5 times, my minimum is in the fifth. It will be in the mid.
Hmm.
So I will go to the mid
Hmm.
and then try to go because I don't have any comparison, right? I should have something to compare to say whether to go left or right in the binary search.
I think I got an idea, sir, on what basis we can take decision. Like
Hmm.
suppose we have our mid, and we are checking in the right. If the right is having increasing number and the left is having decreasing number, then we will move towards left. Like
Hmm.
if the right is having increasing number, then we can reject the right portion, right? Since we
Yeah.
need the minimum number.
Okay.
So,
Yes. Yes. Correct. So this is the index. Okay. So this is index, and this is the value. Uh, Input value. So yeah, we can apply this approach like we can directly check the middle element. Okay, suppose we have total 10 elements here, so we can look either 4 or 5, either by any formula like 0 plus 9 divided by 2, so you are getting 4. So we are looking this direct 4 index, and after that, after checking the middle index, how you can figure out that that element is a minimum element or not?
Yeah, I will. We will can check the next index compare as Muhammad said.
if in the right there are increasing elements,
Hmm.
so still we are not to the minimum, so we will go towards left. I think that's good.
Yeah, first thing we will check what is the condition for finding out the middle element. So you can see here, this is the middle element, okay, and the both element which are coming after and which are coming before this, both are greater than this.
Sorry, what's that?
You can see this is the minimum element in this list,
Okay, we are taking that.
okay.
Okay.
So you can see the next element and the previous element is greater than this element, okay.
Both will be greater.
Yes, so this is the identification of the minimum element in the list.
Yes,
Okay,
yes.
if you are looking the middle element, then just compare that element with the next element and the previous element. if
Both is better.
huh,
Correct.
Both are
if
greater.
if both are greater, then that element is a minimum element in the list.
Else, like Muhammad said, we can go left or right based on the
Huh.
yeah.
Yeah, so this is the one condition to identification of the minimum. Otherwise, suppose if you are pointing to this as a middle element 6, okay, so in this case you will compare the same three element, like this is the middle element, next element, and the previous element, and based on this comparison you can decide which side the minimum element will come. Okay,
Next is
so if sequence is like this, so 3 4 5, so this you can see this element is so this
right is
what
greater and
what
left
is,
one is
yeah,
smaller.
like this is the order.
Hmm.
Okay, if you are getting this type of order, then
Can move towards
definitely you have to move to
left.
left side, and you can directly skip the right part. Okay, you can directly skip the right part. Okay.
And, if we have, oh yes,
Thank you. We will try to code.
Just try to figure out, write the code for this. And also one condition you can apply as the base condition: if this first index element is smaller than the last index element, you can directly return the answer this.
oh, what was that?
Suppose if list is given in the already correct order, so like this 1 2 3 4 5, okay, in this case this is not rotated any number of times, so answer should become 0.
So how are we getting that
Aha.
list is in correct order?
So you can simply compare if the first element of the list is
Oh,
smaller than the last element of the list,
yes, yes.
then return the 0
Then there
here.
is no actually that rotation is.
Yes, yes. Okay, so apply the, you can also write this condition as a single check.
And the decision for going to right, what would be?
Decision for going to right. Okay, so suppose you are coming. Okay, 1 second. Okay.
Next is less than mid, then we can go to the right. If next of mid is less than mid,
Left.
No,
left.
suppose if we are coming at this point. So like the situation, suppose if this list is completely like this, okay, become 2 3 4 5 6 7 9 and then 1. Okay. One second. So for this type of situation, you have to like in the first case you can decide these things. You will come this side, but if you are reaching at this point, like suppose if you have reached at this point, okay, so at this time you have to take this as a next element, and for previous element you have to move to the last element. So you can just use the reminder that things here. You can just find out the index for the previous element by the reminder of the element. So like what is the next? So suppose if you are getting mid equal to 0, okay,
Actually,
so
बट सर जैसे प्रॉब्लम इज जैसे राइट में हमारे पास इंक्रीजिंग ऑर्डर में डेटा था, तो हमने सोचा हम डिसीजन ले लेंगे, तो ऐसा भी तो हो सकता है कि उधर रोटेशन हुआ एंड लेफ्ट में इंक्रीजिंग ऑर्डर में डेटा आ जाए, तो फिर क्या दोनों के डिसीजन सेम होंगे?
नो, व्हाट यू आर सेइंग, इफ लेफ्ट में
इंक्रीजिंग ऑर्डर में डेटा रहे हमारे पास।
हाँ, तो लेफ्ट में इंक्रीजिंग है।
हाँ,
So,
तो जैसे हमारे पास इंक्रीजिंग डेटा मिल रहा था लाइक इन द राइट व्हाट
हाँ, so हमें इंक्रीजिंग ही मिलेगा हमेशा। Okay, so if you are looking here, so if you are finding out the middle element, so this is the one condition. Otherwise, you will always get the increasing order at every point. So you can decide simply. You can move to the left side always.
बट दैट वुड गो रॉन्ग ना सर, जैसे हमने 3 4 5 में तुरंत डिसीजन ले लिया कि हम लेफ्ट की तरफ जाएंगे क्योंकि इंक्रीजिंग ऑर्डर में डेटा था।
But this is actually we are just looking as a circularly. If you have just moving to this side, okay, and you have reached at this 2.
बट व्हाट इफ वी आर इन द लाइक समवेयर बिटवीन लाइक, एंड वहां हमें कैसे पता चलेगा हम लेफ्ट में कि राइट में, क्योंकि डेटा तो इंक्रीजिंग ऑर्डर में दिख रहा होगा हमें।
No, we will always move to the left.
यस वी विल मूव टू द लेफ्ट, बट ऐसा हो सकता है ना सर कि हमारा मिड ही गिरे लेफ्ट में। वो वाला लेफ्ट वाला पोर्शन जो जैसे 8 9 10 दैट वाज अ डिफरेंट इन
हाँ
पार्ट, एंड 1 2 3 4 5 6 दैट वाज डिफरेंट पार्ट. तो व्हेन वी आर मेकिंग डिसीजन इन 1 2 3 4 5 कि इंक्रीजिंग डेटा होगा तो हम लेफ्ट की तरफ चले जाएंगे.
हम्म
बट इट कुड हैपन कि लेफ्ट में जब हम गिरे तो वहां पे भी इंक्रीजिंग डेटा होगा. तो आई
हाँ
थिंक.
so that actually I'm just giving this example now.
हम्म.
So in this case, we are looking at this point, like this point. Okay, so we are getting the increasing data. Okay, now based on that, we will decide this. We will move to this side. Correct?
Yes, we will move to that side.
Huh.
Okay.
So after that, we will again find out the middle element. So this is the
Mhm.
middle element. Again, we are getting the same. Okay. Then we will move to this side. And when we are reaching at this point, so we have to check what is the actually every time when we are comparing between the middle element with the previous and next, correct? Suppose mid we are getting 4 index, so we will calculate the previous or next. So previous will be 3 and next will be 5, correct?
3 5 4.
So,
With 4 we
this
had
is
3
the
5.
4 index and this 3 index and this 5 index.
Hmm.
So in this manner, how we can decide this previous index and next index. So we can use the reminder things here for the next things. Like suppose for next, if we are moving to this side, so how we can decide the what is the left of this two.
Mhm.
So the left of this two should be 1.
But what if we are not on the edge? Could you just write an example? What I am trying to say is that suppose we have uh, 4 5 6 7 and from 4 we have started like
Hmm.
4 5 that rotated
Then
6 7 8 and 1 2 3 like 6 7 1 2 3 whatever. So
5, 6, 7, 8, 1, 2, 3. You are saying?
yeah. So when we will take the mid, it will
So
fall
like this
in the
0,
first.
1, 2, 3, 4, 5, 6, 7. Okay.
Hmm.
Yeah, so we have total 8 elements. So
Yes.
8, if we divide by this, so like
Suppose in
0
the
plus
3.
7, and we are getting 3.
Suppose on 7 we are getting our mid.
So this is a mid.
Now how we will take
What
the
is the previous and what is the next index
6
is
and 8.
8. Okay. Now we will compare. If our element is coming this side, okay, so this is the increasing order we are getting.
Yes,
So we will move to this side.
exactly. But our minimum in the right side.
But we will reach at this at that
Yeah,
point.
yeah. Let us proceed. We will hit 4, right? After 4, how to come to 1?
So that thing. So I'm just going to the step wise. Okay.
Okay.
So here we are looking that our smaller element will come at this time. Just consider that this list is like written as a this in this manner. So 4, 5, 6, 7, 8, 1, 2, 3, like this. Okay, and this is the index of 0, 1, 2, 3, 4, 5, 6, 7. Okay, so now you are looking at this 3 index. So that means you are looking at this point. And you are finding that the order is moving to this side.
Yes.
Okay, in the decreasing order. So you will shift at this point. So what you can do, you can simply find out the next mid element between 3 and this point. Okay, because initially we will start like this. So lower index and what is the higher index, and we are calculating by this 0 plus 7 these things. Okay. So in this manner, we will again check. So like again, we are checking. Suppose we are getting this as a mid 1 index. Okay, 5. Same things again. You are getting this type, this side. So because the previous element of 5 is this, and next is 6. We have.
So first we will move to left, and after that,
So after that, if you are finding out the next one, so that you can find out this is the mid element. So you can again find out this. This is the next element, and this is the previous now. Okay, in this manner you can move to in this manner in this side also.
okay, so we will move like that.
So you can decide like this. Okay.
I'm getting something in mind. Please correct me if I'm wrong. Like हम जो लेफ्ट में जा रहे हैं ना कहीं एक गलत डिसीजन लेकर जा रहे हैं क्योंकि राइट में हमारे पास 1 था. बट व्हाट आई एम सेइंग कि ऐसा भी हो सकता है ना कि हम एक ही डिसीजन लें और वो करेक्ट लेंगे, लाइक हम हमारे पास ए आर आर ऑफ जीरो एंड ए आर आर ऑफ एन, फर्स्ट एंड लास्ट एलिमेंट का एक्सेस है वो वन में, एंड इफ फोर और थ्री इट मीन्स इंक्रीजिंग ऑर्डर में होता तो चीजें अलग होती, बट क्योंकि इधर फोर है इधर थ्री है, इट मीन्स इट इज इंडिकेटिंग कि हमें राइट की तरफ जाना चाहिए, क्योंकि
You
राइट की
can
तरफ
you
थ्री
can
नहीं है।
also you can also add this type of situation when you're comparing the middle element. Okay,
So
so
we
at this time what you can do, you can compare with the first element. You can take also you can add one more condition.
can,
So like you can compare with this the first element. Okay. Okay.
yes, sir, four and
But
three we
we
can
cannot
compare.
figure out. But
We can
So,
compare four and
see, it is if it is a continuous natural number, then it is okay. If it is, say, for example, it is not continuous natural number, I have a sorted list, but 5, 21, 46, like that, if it is there, then the same situation arises. Then it will
हाँ,
be more difficult, right?
I think I got something, sir. Suppose we are comparing four and three, right?
hmm,
And we got seven in the increasing order, right? Six, seven, eight we had. Now we can see four and three. So logically, it is implying na four and three. So why it is three on the right hand, right? It is three on the right hand side, and it is four on the left hand side. So minimum will occur there where we have three. Like क्योंकि सेवन
hmm,
के बाद इंक्रीज हो रहा होता डेटा तो थ्री नहीं आता।
hmm. Yeah, so you
फोर
can at the time of taking decision, if we are getting this type of order, then we can also compare with this last element.
यस
If
लाइक फोर
this
एंड थ्री
if this last element is actually smaller than this middle element,
दैट
then
नॉट
we can move to this side. Okay.
नॉट मिडिल बट दैट फोर फर्स्ट एलिमेंट आई थिंक
No,
फर्स्ट
no, no,
एलिमेंट
no,
विल प्ले
not
अ
first
रोल
element.
क्योंकि सर फर्स्ट एलिमेंट ही तो इंडिकेट कर रहा है कि हाँ वो जो रोटेशन हुआ है वो थ्री के बाद से रोटेट हो गई है चीजें, इट मीन्स थ्री से छोटी वैल्यूज उधर मिल सकती थी हमें।
No, but what happened actually? Suppose we are getting this type of thing. So for like 5, 6, 8, and then 1, 2, 3, 4, like this. Okay, and we are coming at this position here, this side.
टू ओके, so टू, so we will see five, four, and
So
since 1 2 3 increasing data.
now you this condition is again true. So 4 is this element is smaller than this. So you cannot move to this side.
Oh,
Okay. So but what you can do, you can simply you can check this. Okay, so yeah, you can check this if like this. So we are checking middle element. Okay, so we can compare with the last element. If our last element is smaller than this, okay, then we will move this side. Otherwise, we will move this side.
like we will move towards that smaller element.
So here, if you look this, so now the last element is greater than this. So that means our order is increasing to this side. So that means we should move to left in this case.
Increasing, yes, तो left जाएंगे।
Huh.
Okay.
So at the time of first things, we will check this condition, middle condition. Okay, if we are getting okay, so I think if we are getting this condition true, okay, so that we can directly return the answer. Otherwise, we will always check this. We will compare this middle element with the last element. We can decide based on this.
I think that is looks a better solution. Always go to the middle. First case is like you said, see
This
the
is the
first and the
middle or
last.
not?
Yeah. So second case is go to the middle and then compare the middle element to the last
Last
element,
element.
and then take the decision to go right or left. That is
Yes,
the
yes,
best
correct.
approach.
Yeah, so just try to write the code in this manner.
Right, left. Formation. So, sir, could you just give the finish up like last one? That 4 5 6 we had now. So, what algo we finalized?
So algo is actually first things. First condition we can apply here if the first element is smaller than the last element. Okay,
Hmm. Hmm.
you can write this constant check. Uh, then you directly return the answer 0.
Yes. Hmm.
Okay. After that, we will always check in the each iteration if we are getting made. Okay. Then we will find out the next element and last previous element.
Okay.
Okay. And if our value, if our this value mid element is smaller than the previous and the next,
Hmm.
okay, then we will return directly this answer.
Directly and
Okay. Otherwise,
mhm.
what we will do, we will just compare the middle element with the last element.
Middle with the last.
Hmm.
And if last one is smaller, so we will move towards
Yeah.
there. Okay.
Okay,
So
move to the if yeah, so middle element is greater than the uh, last element.
okay, so we will
Then
move
we
towards
will
that
move to
smaller
the right
element.
side. Right side. No,
So
sorry, left side.
so in that case, that 4, 5, 6, 7, 8, 1, 2, 3, we have to move towards right, towards one that
Hmm.
direction. Na? Okay, smaller one. And 8, 6, 8, 1, 5, we have to move towards the smaller one. Okay.
So run the while loop and check this condition.
Uh, okay. Left. That condition. Five. is sorted. We can check, right, if we are at mid.
Okay. Anyone have done?
Trying, sir.
Sir, one test case is failing for me. Can I share my
So that is also failed for me. So I have corrected that. Maybe you are doing the same mistake.
Done,
Let
sir.
me open. Who have done?
Same one test case is
Done,
failing.
sir. Done.
I don't know.
1 second. Who is talking? Karthikeyan?
Yeah, for me also one test case is failing.
Okay. Who done?
Sir, this is Pradeep. Done.
Pradeep. Okay.
So,
Yeah. Okay. Let me check. Yeah, Pradeep code I am checking first. After that, I'll check the others. Okay. Yeah. So Pradeep, what is doing? N equal to length. Yeah. Okay. If n is less than equal to 2, return 0. Okay. So that means only one element. Okay. Fine. So left and right 0 and n minus 1. Okay. While L is less than equal to R. Okay. Fine. Middle element. Okay. Yeah. This is the first R and R minus 1. What is this?
sir, last element R.
Okay, so R is actually 0 and okay, 0 minus 1 minus 1. Okay. You are using that concept.
R
Okay.
is sir n minus 1.
No, actually here R minus 1 is written, no? So I confused. But it become a last actually. Because the R is 0, so 0 minus 1 become minus 1 index. So that is also pointing to the same.
Sir, R is n minus 1. Length of L. Sixth line.
Huh. No, here R is equal to okay, R equal to
N minus
n
1.
minus 1. And then first R is
First R is last element and comparing with the previous one. R minus 1.
no R equal to n minus 1, and this is
N minus 2.
so you are just trying to compare first and last, now.
Last with the previous one. If my minimum
That is
smallest element is at the last, then I can compare this at the ninth line.
okay. Okay. Yeah. So this is the n minus one element. Okay. This is happen R. Okay. But this is actually a comparison between first and last. We can say that
Sir,
you have written in this manner this first element and this is the last element. Are you updating this R value anywhere in your code? Oh, you are
yes,
updating.
sir. Yes, sir.
Okay. Then okay, fine. So this is one condition you have taken. This condition is for if this become LM. Okay, this is the middle element. And otherwise you are taking this if middle element is greater than the left element. So that means you are setting your left equal to m plus 1. M plus 1. If middle element is greater than of the left element. Left means first element. That first element. Okay, first element.
Sir, my approach here is I want to see whether there is a continuity in the increment or not. If middle element and left element have the continuity, so that means my minimum most element should be in the right side. Either
No,
minimum
in this LF condition, you are comparing middle element with the
left
left
first
element.
element, yeah,
Correct?
maybe left.
If middle element is greater than the first element,
Yes, sir.
so that means you need to move to the left side. No,
No,
I am asking that why you write in left equal to m plus 1. Okay, you are moving to right. Well, let me check this thing. You are comparing with the first element. Suppose middle element is greater than with the first element. So like this case, suppose 8, 9, 10, then 1, 2, 3, like this. So you're comparing this middle element with the first element. If middle element is greater than this, okay. Yeah, you need to move to this side.
Yes, sir.
Hmm. Okay, okay, fine. Otherwise, you are sitting. Yeah, okay, okay. That is also fine. Okay. So, who is getting error in your code?
I'm
Sir,
good.
I have
Getting
also.
wrong answer.
Karthikeyan?
Yes, I will share my screen. I have one error coming.
Yeah, I have opened your screen.
Yes.
Huh. So, actually, what happening? I have also did this mistake. Maybe.
I'm not able to get the proper else condition because this code I'm getting one
No.
error.
If you have
So
done this, you can leave this. No.
no. It is without else. It's giving me one case is not passing for me. I'm
So
trying what
that
is
is
the else
actually.
condition.
Okay.
I'm not able to figure out the else condition. If I remove the else condition, three cases are I'm able to pass.
Hmm. So what error you are getting for the wrong condition?
It is not even coming. 1 second. I will just
No, error will
remove the
come.
else
Hmm.
and then I will.
Let me run. Okay, so 1 second.
Yeah, the test result actual no output is coming. It is telling index list out of range.
So index is out
Line
of range
20.
actually.
Line 20.
20 line. 20 line is not. Oh, this is the main. Okay, 1 second.
File and then if
Line 10.
yes, line 10.
So what happening actually for this condition when we are comparing this? So mid plus one and mid minus one. Okay, so there is a chance maybe your bid is actually reaching at the last index. Okay, suppose if your mid is actually reach at the ninth index, if you have only total 10 element, and
Yeah,
after
I'm not
that,
that end case. I'm not able to figure out what to do. What to do in that case.
so in that case, what you can do if you are getting this mid, so mid plus one, what you can take, you can just write the one condition. Suppose if you have reached at the nine mid equal to nine index, and nine is the last index, and we want
Mm-hmm.
to check with the next index, but there is no index after that. Okay, because
Mm-hmm.
of that, we are getting this index error. So what you
Mm-hmm.
can do at the time of calculation, after reaching at the last index, you should come at the first index to check. Okay, so just use the reminder condition here. So like we can write. Uh, so what is the length of the list? Actually, we can use the reminder percentile. Okay, so this is the one handle. That means if our mid become a last index, so by this
Mm-hmm.
condition, our mid plus one become a first index.
Mid plus if it is last index,
Uh,
then mid plus
so
one.
nine. Suppose we have 10 element. Okay, and 10
Mm.
this mid become a nine index. Okay,
Oh,
so now
plus
if
one, then we will become first. Okay, yes.
so we are using 9 plus 1 and the remainder by 10. So that's the 10
Okay.
remainder 10 0. So in this manner we will handle this error. Okay, and same things we have to do here, this mid minus 1. So let first check this is handling by this or not. Yeah, passed. Okay,
Yeah,
but
when we hit the first, same thing happens to the
so
first.
same
So
things
for
you
that
can do.
also we need to.
That
Okay.
but you have
Okay,
to.
this is what we were discussing to have the reminder.
Ha, ha,
Okay,
ha.
in the while discussion we were telling to use the
Yes, yes,
divide
in the circular way. If you have reached at
the
the last
circular.
condition, or you can take any another, you can write any other prevention for this, but this is we can also use.
Okay, okay,
Okay,
okay.
so for this mid minus one, you have to add length first. First, you have to add length first. So like len of L, then after that you have to apply the this reminder things in this part,
Hmm.
because 0 minus 1 become a minus 1,
Yeah,
then
minus
it
one.
will give
So you
error.
add and then do the.
So this is
Okay.
ln of n.
Thank you, thank you, thank you, sir. Thank
Yeah.
you very much.
So now this condition, this error will remove. Hmm. So same, I think Rasi, who got the error? One,
Sir, I also.
yeah, Deepa.
Yes, sir.
Let me open your also. Those who have done, just move to the second problem. Second problem is little bit tricky, okay, but still try to figure out. Uh, Deepa, 1 second. Deepa, Deepa, Deepa. Okay, so same, I think error. Oh, you have written that recursive solution.
Yes, sir.
Okay, recursive. So mid equal to low plus high equal to 2. If late this condition is become true, then you are getting this mid. Otherwise, LF if mid minus 1. Okay. No, why you written this condition?
Uh,
LF.
Sir, to check if we want to go to the left of the mid.
Okay. But no, we have already discussed now. We no need to compare with the next and previous. So we need to check only with this minimum condition. But decide to which part we need to move. We have to compare with the either first element or last element here.
Okay.
So this condition is not required. So what you can do, you can compare with this only last element. So like we remove this and we can write suppose if we are getting low and high every time, low and high, so mid become, if I suppose if I'm writing high, let me check where we need to move. So if our mid element is greater than the high element, then we need to move to the right. Okay. The high. Low, no, this become mid, and this will remain same high. Hmm. Otherwise, this will become, this will remain same low, and this will become mid. Okay, let me run again. Again failed. Still it is going to, okay. So what we can do, we can write mid plus 1 and mid minus low minus, sorry. List index out of range. Here now we are getting the index error. So that we can remove by this reminder things. Okay. Now, oh, okay. So here you have to calculate the length. Low, high, okay. So we list of L, okay, length of L. Getting error.
Same.
Okay, there. Oh, I have written this here. And here we have to add len first, and then we
Sir,
can.
this we are doing because of if the mid is at the last of the.
Ha. If our mid become a either last or first, then
Okay.
we are just reducing one index. If we have reached at the first index and we are reducing one index, so it will give error.
Okay.
Okay, and same for the okay. So it is not give the error. So here, if suppose if mid becomes 0 and we are reducing -1, so it become a -1, and -1 is pointed to the
Last
last
index.
index. So I think this part is not needed. So this will be handled easily. But yeah, but when we are just writing mid equal to last index, okay, and we are adding one more, so that will give error because that index is not exist actually. Okay, now pass.
Okay.
I'm also getting error.
Uh,
Not error, like wrong answer.
then okay.
Allowed. Actually, I tried in this way, like it was working, taking decisions based on.
Mhm. Okay, so what you are doing? First L H. Okay, left low and high. Okay, 0. Okay, this is area -1 main index, middle index. Okay, 0. Okay, after that you are calculating here. Okay, so L is less than equal to H is L plus H minus L. Okay, fine. So if A of L is less than equal to A area of high. Okay, answer fine. If
What I'm getting here wrong, na, sir. Like in if I want to find the minimum number,
hmm,
we can do na, like we can go to left and we can update our minimum. But I'm not able to update our index. Like
no, why you mean what is this MN index?
minimum index I was capturing. Actually, earlier I had an idea of this one, like getting the minimum. This one, is it visible now?
So for this question, actually, okay, you are not checking this condition. One condition you are missing. Okay.
Actually, earlier I had this one, like uh, I had the logic to get the minimum number in the array,
Hmm.
and I was trying to convert that to get minimum index. The portion I commented out, we can get the minimum number in the array.
No. So okay, you are repeating this process. Hmm. And you are also taking this equal sign. And what you are getting? What error you are getting?
Wrong answer.
What is this MN equal to?
Actually, that for minimum
Okay.
number I was using
Just
earlier.
remove this.
Mhm.
Okay, or let me just. Okay, 9, 8. Actual output it is 8, and here 3 you are getting 2. So this index you are getting, but and above score is past 0, 4. Okay, so what happening? You are returning one answer from here. Okay, so
Mhm.
either this answer is returning. Okay, otherwise this will return
Last one.
like this. So for this case, we are returning the answer from this first condition
Mhm.
directly. But for this 4 case, we are getting 4 answer, and 4A correct, but that is not coming by this. L and H. Oh, that is also becoming maybe coming by this.
Actually,
Okay.
I'm doing wrong, sir. Actually, what we
No,
need.
what happening actually is, so if I think if we add one here, so I
Mm-hmm.
think you are getting one less. Let me just quickly check. Field. Why? Oh, what not it? Okay. So you're never reaching at this point.
Hmm.
You're never reaching at this point. So instead of this, just write us that condition. Okay, if middle element is smaller than the previous and get smaller than the next. So that write that condition also in this while
Like with
condition.
the, uh, I think we have two conditions, na, sir. 16 and else part. So if it is middle is greater than we are handling and less than also in the
No,
else.
that is fine. That is fine. But actually, what happening? You are always get. You are reaching at this condition. You are not getting this final return.
Okay.
Okay. So here, this is there is a chance you are getting wrong at this left and edge things.
Okay. Just give
Okay.
it 30 seconds, sir. One more test case was passing earlier. It was I think this one. Okay. Like first one is failing only now. So could you run now?
Oh, first one failed. 0. Hmm, the 4 case and this is. Now you just go, just take this input, okay, and check
Mhm.
manually step by step how your algorithm is working for this input.
Okay.
Okay, so when you will apply the dry run your code and on this input, you will also understand your code logic.
Mm-hmm. And then four, 0, 1, 2, 3, 4. One should be returned. Okay. Actually, for that part, I was okay. I will do the dry run. And already.
But things I'm just understanding you can middle element, okay, and then left and then H. Okay, this point. L equal to mid plus 1.
Actually, in that two conditions are I tried that idea. If the left half is sorted, so we can get the minimum from there and we will move towards right. And if the right is sorted, that idea I used.
L equal to syst. Okay, one thing. What is this? Sys dot max size? Okay, this
Actually, I was
infinite
capturing
something.
minimum. Yes, sir. Hmm.
Max size. And after that, you're figuring a minimum. Okay, just apply the dry run. I'm not also able to understand the logic correctly.
Mm-hmm.
Uh, Here, middle element is greater than the left element, then you are setting this. This is fine.
So in
Hmm.
that idea, in line 16, if condition, actually I'm checking if the middle one is greater than the first one.
No, one actually what may be happening.
Mm-hmm.
This is okay, okay,
Mm-hmm.
and here you are setting else part without checking. So we have one more condition actually remaining. So at the time this condition is not satisfied. Okay, okay, one second. You are comparing with the first and last, middle and last only. Okay,
Mm.
then if it is uh, middle element. Finite. Uh, so now past. So when I add, when I remove this minus one, na, actually during this, because you are not checking that middle condition and you are shifting your left and low and high.
Mm-hmm.
So every time you are reducing, either you are adding one to the middle or either middle to the minus one. So there is a chance if you are reaching at the middle point, and that is minimum actually. Okay.
I reached at middle.
That is actually a minimum element, but still you are checking your this condition. Middle element is greater than the left and or the right, and
Mm-hmm.
you are entering into the same else part or if this part. That means you are again moving. So your mid is actually point reached at the minimum element, but still you are moving to the left or right.
It could
At
happen.
that yeah,
Middle
at
one
that
is the answer.
yeah, at that time you are getting some wrong answer for some test case. So now I have just included this middle element for the one condition at least.
Mm-hmm.
Okay, here I am setting left equal to mid plus one, but at the time of setting h, I am not decreasing. I am also including the middle element for the next consideration.
Okay.
Okay, so by this case that actually is now covered. So you are getting for all
Mm-hmm.
test case pass, but
Okay.
still check some or more test case. Okay, so
Okay.
maybe some test
Okay.
case will be complete.
Okay.
Check all possibility.
Okay.
Okay. So now this is the one this type of problems. Other let me just tell you some other problems may also be formed for this binary search logic. Like suppose if one we have one list, okay, and we have some continuous element like 1, 2, 3, 4, 5 without we have continuous element from 1. Okay, so 1, 2, 3, 4, 5, 6, 7 like this. Okay, and some n number. So in this case, suppose now the order is increasing order. Okay, we have in increasing order, and we have also all elements without missing any elements. And suppose for the problems we have removed only one element from the list. Okay, if we removed one element from the list, from this continuous list, then find out that which element is missing.
Oh,
Okay, that problem can also be solved by the same binary search concept with the time of log n.
means we have to
Like we
see
have the
which element
sequence
has
like
been
this:
removed.
1, 2, 3, 4, 5, and then 7, then 8, 9, all that.
We will always have like natural numbers.
Natural number. That means the condition is we have all the continuous number, natural number. Okay, and only one element is missing in this sequence.
Okay. And it can start and end, start from any, like
Uh,
any point.
So any point can be started, but after that we will always get the continuous order. Only one element is missing in this order.
Uh, I think.
Then you can think about the binary search concept to find out the missing element in this sequence.
Uh, so one thing coming, sir. I think we can get this in O of one, like
No, you cannot get in O of n. How
O
you
of
can get
one.
in? How you can get O of 1?
Like suppose we have 1, 2, 3 up to n,
Hmm.
and so if 6 is missing, summation. Okay, okay. No, sir. I have to work on that. Okay, okay.
Okay, so this is one possible problem for the log n complexity. Another problem is the just addition of this. Suppose we have the same order, okay, like 1, 2, 3, 4, 5, like this continuous order, and we just duplicate two element continuously, like 4.
Oh,
Okay, now we have all elements single element and in the continuous order, but in between one element is repeated two times.
okay.
Okay, then figure out the duplicate element in log n complexity.
Mm-hmm.
So that is also a one possible problem you can solve using log n complexity. So these problems I'm just telling you.
Now, this missing and
Ah,
this duplicate. What is there?
I
What we are
think
trying to find with the binary search here? Because
Ah,
I
so
have an
this
idea.
is
actually I'm just telling
meaning
some
something.
what type of problems can be formed for this
No,
log
no,
n
no.
complexity.
That's okay. Just
Mhm.
for a discussion only. I just want to
Okay.
understand what we will try to find. At least that sense is there. We will try to
Suppose
take
you
off
are
in that
given a
line.
list, this type of list. In this sequence 1 to n, we have the continuous sequence in the increasing order. Each elements there's no elements, only one element is missing in the sequence. So that missing elements we need to find in this.
Uh, I have an idea, sir. I think since the elements are increasing, okay,
Hmm.
continuous. So if you are taking one based index, okay, for example, so in the odd index, odd number will be there. In the even index, even number will be there. So I think based on that we can take decision.
Hmm.
Like जब हमारा मिड गिरेगा तो वी कैन चेक कि अगर एक भी एलिमेंट गायब हुआ होगा तो उसका ऑड एंड इवन डिस्टर्ब हो गया होगा पोजीशन लाइक
Hmm.
इवन वाले ऑड पोजीशन पे आ गए होंगे ऑड वाले इवन पोजीशन पे आ गए होंगे
नो सो इवन वाले और ऑड वाले ये नहीं देखना, क्योंकि नंबर कुछ भी हो सकते हैं. ओके,
बट दे विल बी
नंबर 2 से भी स्टार्ट हो सकते हैं, 3 से भी स्टार्ट हो सकते हैं, तो वो एक नहीं है. लेकिन हाँ, ये देख सकते हैं क्योंकि हमारा इंडेक्स हमेशा 0 से स्टार्ट होगा. ओके.
हाँ
हाँ
सर वो टू से भी शुरू होगा तब भी प्रॉब्लम ओके ओके हाँ
हाँ,
सर
वो you can figure out that. Suppose we are starting 0 index and 0 index is 1, and we are directly moving to this 5 index as a middle index. Okay, now what we can do, we can check 0 index is 1, then fifth index should be 1 plus 5 in the continuous order. Okay, so sorry, one that 0 1 plus, yeah, 1 plus 5. But if you are getting the same element at that mid index, so that means there is no element missing in this sequence. So you
ओके
can
मींस
skip this
प्लस
one and you can move to this only. Okay. Suppose one element is missing like 3 here. So what will happen? Actually, you will get this as a 4 index. Okay, and you are getting 0 is a 1 and 4 index is a now 1 plus 4. Sorry, 1 plus if this is not there. Okay,
1
so
plus
0,
4
1, 2, and 3. So sorry, this become 3.
ओके
Okay, and that means third index element should be 1 plus 3, 4. But you are getting 5.
हम्म
Okay, that means your missing element is coming at this side. So
हम्म
based on the index and the value at the index, you can figure out that which side element is missing.
यस सर
Okay, same things you can apply here in the next question, duplicate things. If only one element is duplicate in the whole list, and our list is in the continuous order.
So since it is, अगर इसके पास डुप्लीकेट होगा तो it will give us
हाँ,
one more index. Like अभी हम
yeah,
एक कम index मिल रहा था, but we will get
hmm,
one extra index.
yes.
Hmm.
So that you can also think for the log n.
Yes.
Okay, so these are some other problems. So now the second problems where we can move for the today. That is actually little bit tricky. So anyone have figured out the logic for that?
No, I just did the merge function and then put a formula for median. That's it.
Oh,
All cases are passing because it's already sorted.
That
okay,
will
but then what is the
n log n.
complexity?
Hmm.
So merging function is while only, right? While for unless something is greater, and once it is whichever is greater, you add another while for the remaining
That
two
will
list.
take order of n. No?
Order of n only.
But we have to do in log n.
So this is
Hmm.
oh, this is log n.
Hmm.
Hmm.
Oh gosh, all test cases fast. Okay, understood.
No, these problems are very
I didn't
simple
see
actually. These problems are very
why
simple.
you are
You can
asking
simply
again.
that concat this two list and you can sort apply the sort and then you can figure out the answer. But here
Complexity.
the complexity is the main point.
Hmm. Solution. So give us 2 minutes more to think. Like
Hmm.
What is the problem? Log n. Okay.
So here also you just think about that how you can discard the half part of the list like this. Both lists are sorted actually.
How much function can be log n?
A merge function is not log n.
Okay.
Merge function is
Oh, we
actually
need to
n.
take. Okay.
Okay, you are just
Very
traversing
good.
all the element. Here n is the size of one list,
Hmm.
and we have the both list have the same size actually. N.
Hmm. Can we take the mid of both, median of both, and then do an average?
Mhm. Yeah, that approach we need to uh, apply here.
Seven,
Yeah, yeah, this is correct approach. You have to
seven,
figure out the middle
nine,
element of the each, and then
seven
figure out that which part you can skip.
90 is 9.5, 3.5, 9 plus 4. Yeah, looks like it's coming. At least for the sample inputs, it's coming. So we can take uh, we will find the middle element and then take take the right hand side and the left hand side, or plus 1 depends on the length. Take only 2 and then do an average for both, which will be log n log n. Average calculation is only 1, and then another average calculation. I think that should work, right?
Yeah, yeah. Approach
Okay,
is going to the
let me
correct side.
see. Okay.
Okay, so let me discuss some base case for this. How we can figure out the base case. Okay, so every, like if you're writing the binary search condition, so at some point we have to stop. Okay, so how we can, so we are reducing the size. Okay, if we want to find out the solution in log n time, definitely we have to reduce the half size at the each step. And but after doing this process, we, how we can figure out the our solution also. Okay, so some base case we have to define. So first things, if we have two lists, okay, so like this 1 3 5 7 we have, so there are multiple possibility because the condition is given both list size is same, so that may be either even or that may be either odd. Okay, so and our value may also be repeated in the both list but not in the same list, like I think same list is also repeated. Okay, so 2 4 5 8. So this type of list is given. So suppose one case, if we have uh, this situation, so like this 1 3 5 and 7 9 here, and another is like 2 4 and 5 and 8 and 10 here. Okay, so we will do the same things. We will figure out the middle element. Okay, every time we will figure out the middle element, and based on the comparison of middle element, how we can figure out that which part we need to check to the next time. Okay, so that things we have to decide. So that means we will check the middle element of the first list and middle element of the second list, and then we will compare the elements. And after comparison the elements, then we have to decide which part we need to take from the which list, like this. Okay, so there is one condition. If suppose if we are looking the middle element and both are same, so in that case these two middle element will always come in between in the final sorted list. Okay, because why we are saying this, because all the elements you can see on the left side are smaller, all the elements on the right side are greater, so you can see the element sizes are also same. So 4 here, 4 this side, so these two elements will come in between. So after writing the sorting element of the by merging this, so 1 2 3 4
So why
5.
should we merge this? We take the list separately
No, we are
and
not
then
merging,
see. Uh,
but I am just figuring out the logic. So,
okay, okay.
okay, I am not merging anything, but I am just figuring out that if both middle element, if you are looking the middle element, if both middle elements are same, then we can directly return the answer, the 5, any one element. Okay, so 7, 8, 9, 10. Okay, so if both elements are same, so you can directly return this is the answer, because average of these two elements will remain the same. So 5 plus 5 divided by 2, you will get the 5. So this is the one base case you can apply here. Okay, this one condition you can make. Another condition is, suppose if we are reducing the size every time. Okay, if we are reducing the size, and sometimes if our length list will remain 1, n equal to 1. Okay, that means we have a list, b list. We have only one element to check in the one is in this list 1, and we have only one element in the another list like 2. Okay, so that means we are reducing the size every time, and if our length become 1 now, so you can directly return the answer, because answer will be simply just add the all value divided by 2, like this. Okay, this will become a median. So this is a constant operation we can do if our length become 1 after reducing. So we are reducing our size of the problems. So that means at any time you will reach at 1 size or maybe 2 size like this. So at that time you can directly return the answer by this condition. Okay, so this is another base case. Same things we can also do for the 2. This is also not tough, because if we have two elements in the list and both lists are sorted like this, 1 comma 2 and b equal to like 3 comma 4. So what you can do, you can figure out the element, maximum element of the one list, okay, above list, and minimum element from the second list. So max of a plus min of b, like this, and divide by 2. So that means you will get max of this is 2 and this min of this is 3. So that means after sorting, you can see 1, 2, 3, 4. These are coming into between, and you can directly return the answer, 2 plus 3 by 2. That will be the median. Okay. So for median, actually, if we have input list size n equal to even, after merging, you will get even size. Okay. If you have n equal to odd of the each list size, still after merging, you will always get even. So that means you have to calculate this median by the average of two middle elements. Okay. So these three cases you can make as a base case. First case is if our middle elements are same in the both list during the process, you can directly return the answer, same middle element. If your size is become 1, then you can directly return the answer, the element of the first list, second list, and divide by 2. If our size is become 2, then you can also return, find out the max of a and min of b, then divide by 2. You can directly return the answer. Now the remaining condition, else part, if your size is greater than 2, and how you can decide which part you need to check to the next part based on the middle element comparison. So I'm just giving the example here. So suppose mid A is the index of the A list, okay, and mid B is the index of the B list, middle index, okay, and we are comparing these elements. So based on this, we have already figured out the solution for if our A mid A become equal to B mid B, okay. So if we are getting this situation, so we can directly return the answer, return our A mid A, like this, okay, because both are same. After getting the average, you will get the same. So you can directly return this answer at this point.
This point I didn't get it. How is this?
So situation like this, if middle elements are same, so I have mentioned this example. If you are calculating the middle element of the A list and middle element of the B list, okay, and both are same, so that means these two elements will come in the in between after merging, definitely.
Yeah, this case is clear.
So
The
this is the
other
same
two
case.
case is also clear.
uh,
But what is the both three base cases? It's clear.
so this is the one,
After that,
test base case I have just written. So A of
this is
mid
what you're.
A,
Okay.
B of mid B equal to both are same, so we can directly return answer. Or you also do like this. So B mid of B divided by 2. Okay, like this. Now this is the condition are remaining for if our A mid of A is greater than B of mid B. Okay, so then what we should do, and so this is the one condition, and other condition is if the reverse condition of this. Okay, so if A of mid B is less than, okay, B of mid B, sorry, A, this is A and this is mid B. Okay, then what we should do, so these are the part, so for these condition are the part, basically we will reduce the size, half size of the searching area. Okay, now how we can figure out that which side we need to move to the next level. So suppose we are taking some example for this type of situation. Okay, so like for the same example, in this case, sorry, 1357, or we can take the odd example, so we will get the things clear. So 579, and I suppose, so this is A list, okay, and this is the B list I'm writing here. So like 2, uh, 3, and then 4, 5, then 6. Okay. So both we have the both same size 5 element. Okay, and now we are looking the middle element. So you can see we are getting this element as a middle element. So 0, 1, 2, 3, 4, and same for 0, 1, 2, 3, 4. So we are getting the two index as a middle. So and this is the element 5 and 4. Now which condition we are getting here? So here A mid is greater than B mid. So A of mid A is greater than of B of mid B. Okay, this condition is true. Now just figure out that which part we should access further if we are getting this situation. Just look this list and you can figure out that. So that means we can remove half part of the both list in this situation. But which side actually?
we can remove the left side, right?
Both left side,
Yes.
A and B.
Yes.
So I'm also writing the merging solution for this. So like 1, 2, 3, 4, 5, and 1, 2, 3. Oh, 2 times 3, 3, 4, and then 5, 5, okay, 5, 5, and 6, 6, 7, 9. So we have, after merging we will get this. Okay, and then what is the median? So like this 1, 2, 3, 3, and this is the median. Okay, so 4 plus 5 divided by 2, correct? 4.5. But you are saying that if we will remove left part of the both. You are saying that.
Yeah. Basically, we can remove. In this case, we just take the average of list A, average of list B, and average of both the list. We
No,
should give the answer.
we are calculating the average, then it becomes an order of n.
Yeah, because we don't even think. For me, what I'm thinking is this two cases also not necessary. We just take the length and then get the average of the middle elements, and the list B average of the middle elements, average of both should
No,
give the answer.
that will not always Correct. Suppose I'm giving the another example. So like we have 1, 2, 3, 4, 5. Okay, and after that 3. Let me add one more, so 6. So if I'm writing the 4, 5, 5, 6, 7, 8, 9. So like this example, we have total 7 element. You are looking at middle element. So this is the middle element and this is the middle element. So you are saying that answer will be 3 plus 6 divided by 9. Okay, correct?
1, 1, 2, 3. Yeah. Yes.
9 divided by 2 and 4.5.
4.5.
Let me just write this 1, 1, 2, 3, and 4, then 4 again. So 4 again, 5, 5, 5, then 6, then 6, 7, 8, 9. Okay. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Yeah. 1, 2, 3, 4, 5, 6. So these are the two middle element now. So but answer should become 5.
2, 4, 6. Okay.
Okay, so this is not the direct case.
Yeah.
Okay, so what we can do, so now just think logically for this. So for this example a and b, okay, so this a and b, what condition we have get, we have got this a mid a is greater than b mid b, correct? So this means this element is greater than the this element, okay, 4. So that means how many elements are smaller than this 5?
We have 1,
How we
2.
can conclude this? How many elements definitely be smaller than this 5?
It should be the elements of A left hand side plus all the elements of B left hand side, including 4, middle element of B.
So we can ensure that these two elements is definitely smaller than this 5.
Yes.
Okay,
And these 3 also.
smaller, or we can also say but smaller or equal to, but no, it is not possible that the left element is greater than this.
Yes.
Okay, these two. And also because we have already checked this, because this 4 is smaller than 5, definitely all the elements which are coming on
Definitely.
this
Yes.
side are definitely smaller than this. Okay, so what is the position, actually what is the possible position for this 5? Minimum position is, so definitely this will be after 5 element, you can see. So we can see that if we write the final index 0, 1, 2, 3, 4, 5, so after merging we have total 10 elements. Okay, 6, 7, 8, 9. So definitely our this element 5 will become after this index. Okay, this side,
Yes.
correct?
Yeah.
And what should our median index, that will be 4 and 5, these. Okay, so that means we got this 5 on this side, and we are also not sure this our this 5 value will come at the 5 index, or it may also come at the right side, because you can see, suppose this side is 4 is written, 4 is written, you can see this 4 is will also come before this 5, this 4 is also come before this 5. So this is the lowest index possibility for this 5 element, but this may also be shift to this position 5, 6, 7, because the elements which are coming to the right side, so this side definitely be greater than this. Okay, so two elements definitely will be come to the right side of this 5 element. So the possibility of this 5 index will be from 5 to 7 only, this part. Okay, that means this 5 value can maybe come at the 5 index, maybe come at the 6 index, maybe come at the 7 index. But it cannot be come at the 8 and 9 index because two element is already available after this greater than. But definitely they will become on the right of this 5. So, and also we can think that this 5 element definitely we will come before this 5 index. Okay, so based on this we can decide our next searching criteria. So where we need to check further if this condition is true. So that means we need, because our median index are 4 and 5. Okay, so our median index are 4 and 5. So that means this side there is no meaning, because if our 5 is coming at the 5 index, so that may become at the median index, but these two elements definitely will not become at the median index. Okay, that middle index, because if you see that if our 5 is coming at this position, so the 7 and 9 definitely will come on this right side, and we are only looking only this locations for the median. So these two elements we can ignore from this side. Okay, so that means next part, for first list we will look only this side. And what about the next B list? B list we will look only
We have to look the other side, opposite side.
because definitely, because we have already seen that these two elements, because this four definitely will become before this 5. These two elements cannot become actually at this index.
Yeah.
Okay, so at that time we can directly ignore these two element also. Okay, and we can look only this side for the next process. So for this condition, if our a mid a is greater than a b mid b, so at this situation, just for next iteration take this part, that means a low to mid, okay, and b mid to high. This part we need to check further. We can remove this two half part if this condition is true. Okay, and the reverse condition, if the same things for the reverse, if our b mid become greater than a mid b, so the reverse logic we will apply. We will take the right part for the first and left part for the b. So just reverse the condition. So only these two condition you need to write here. If a mid is greater than b, so just apply the same binary search again, only on this first half, and this is second half of the b. Okay, first half of the a, second half of the b. If the another condition is true, then take the second half of a and first half of b, including the mid. In this manner, your list size will reduce on the each time, and you will reach at the base case, either n equal to 1 or n equal to 2, or both mid equal to same, and your code will stop, return the answer. So I hope some idea is clear, so you can try to write the code with me. I am also writing the code. And is anyone try this code?
I will try now. Yes.
Huh. Okay, so write all the base case things. Check. Okay, so yeah, so I'm writing the recursive code for this because we will reduce the size uh, every time, and we will write the base case for this. Okay, so base case I've already defined. So like length of the list equal to, we can use any one list. And each time in the recursive call, okay, so the our input list size should remain same. Okay, so that is also one criteria for this, because the problem condition is given that both list size is same. So in each iteration your list size should be remain same. And equal to, we can write like this. Okay,
This while checking the middle element
Hmm.
are equal. If the length of the list is even, then how to take the middle element?
So you can use the formula same, so that first index and last index and flow division by 2, like this. So
No,
if
but it will not give the actual because it will be having two middle element, right?
so but in the binary search also we also do the same thing, no? So we, like, you have 4 elements in the list. Okay, so 1 2 3 4. Now for the calculation of middle, you will just calculate the 0 and plus 3 flow division by 2. Now you will get 1. So this will consider as a middle. Okay, yeah, you have to update little bit here. So because if
No, for the base case, I'm telling, because the first base case is if the middle elements are equal.
ha
If the list is odd, then okay, it's very clear.
ha
The list is even, then which to compare it as middle? All
element,
uh,
so
it will be two, right? Otherwise, our this one will.
so that is the one criteria you have to cover here. For middle checking, for the even case, okay,
Mhm.
first list you have to take the same element, this element as a middle, but for the another list you have to take this element as a middle. Then if both are same, then these two will come at the correct middle position. Okay,
Mhm.
so you can write the code for this. If the length is even, then consider this index as a middle for A, and this index, one more index, okay, for the middle for B. Then this equal condition will be covered. But for the odd case, take the both same.
Yeah, yeah.
Okay, so I'm just writing the recursive code for this. So I define another code. So like, A of SB, B of SB plus this is of A of this type B mid A. Okay, anyone have written the code?
For me, everything is coming as error. No condition is.
Okay, so let me check. Oh, okay, I have written the code on the Alauddin. Oh, sorry. Oh, this is not. Oh, yeah, correct. Okay, so yeah, this is the code. Let me just check with the test case first. All failed. So,
Same.
so
Not coming.
yeah, so this is giving list and int. It is the unsupported operand type of S for list and int. Okay, so line number 21.
Syntax error.
A, so here we are passing A, B, 0, oh, okay, len of A. This is -1. Huh. Now this side is okay. Okay, still error. So list is max of SA plus int object is not retrievable. Line number 13. Okay, return max. Okay, so max of we are passing to our okay. So this is not plus, this is comma, and this is also a comma. Okay, now pass. Yeah. So I have written the code. Just let me go through this. So what I am doing, I have written the recursive code. Okay, so I have just called this recursive code from this main code find median A and B. What I'm passing in this code, because I'm writing binary search code, similar type of code, but I'm not using slicing. So I'm passing all the first index and last index for the each list. Okay, so in that way I'm not using slicing, and our code will remain with the log n complexity. So this is, you can see 0 is the first index of the first list, and this is the last index of the first list. Okay, and similar for the second list B. This we are passing the main call, recursive call. So median, here you can see we are taking this index. SA means starting index of A list, and this is the last index of the A list, and this is the start index of the B list and last index of the B list, similar. Okay, after that we are calculating the length of the list, because this time length we will calculate by the uh, because this is recursive call, so every time we have to call calculate this length by last index minus first index plus 1 using this. Okay, so any one list we can check this length, because both lists we are getting of the same size. Now after calculating the length, we are simply calculating mid of this equal to n flow division 2, so length divided by 2. So and after that we are setting mid set same for the starting index plus mid, because we are not sure what in starting index we are getting. Okay, so it may be 0, it may be 2, it may be 3 in the another recursive call. So because of that, to find out the middle element, we have to add mid value into the starting index, then we will get the middle index. So this is the common for the both condition, either our list size is even or odd. But for the second list we are checking this. Okay, so we are checking if our list is even, size is even, then we are setting this mid be equal to sp plus mid minus 1. But otherwise, if we are odd, then we are taking as a similar for the first list, SA plus mid, here SP plus mid. Okay, so this is the middle element, mid index finding. After that, we have written the base case. You can see if our n is equal to 1 size. Okay, now we will directly return the answer. Okay, mid A, or you can also do A mid A plus B mid B divided by 2. If our list size is become 2, then we can also return the answer So here actually what we will do, we will find out the max of first element of the both list and minimum of second element of the both list. In that way, you will get the middle two element. So maximum of first element of the both list and minimum of second element of the both list. So you will get the median average.
Can we see my code? Because I did not this way. I did the raw method.
Okay, okay.
Can
So
I share?
first, just quickly say, explain this, okay, and after that I will look.
Yeah,
So,
I understood. I understood this code.
but yeah, this will also recorded, no? So I am just quickly do this.
Okay.
Okay. So yeah, this condition is now for the base case 2, and after that, if you are finding this mid of A is greater than mid of B. Okay, so this is the yeah, okay. So equal case, equal case we have missed. So let me add that also. So else it is actually if is if we have to write LF, everything we have to write with LF. So LF, and this is also LF. So if A of mid of A, sorry, this is capital A, is equal to B of mid B. If this condition is true, then we will also return the answer. Where I did this, oh, I have written wrong in the above condition. Okay, sorry. I return A of mid A. Okay. Yeah, this is true, but I have written wrong here. If n equal to 1, then we cannot write like this. We have to add both because both element may be different. So mid B, and then we will find out the average of this. Or we can directly not mid SA. SP. Wait. So if we have one element in the each list, calculate the average of both first single element. Then two element, find out the max of first element of the both list and minimum of the second element of the both list. If both middle elements are same, then we will directly return the answer middle A of the any list. If this first condition is true, that A mid A is greater than B mid B, in that case we will just discard half part. So we will take the first half of the first list but second half of the second list. Okay, and the another condition, we will take the second half of the first list but first half of the second list. So in this manner, we will reduce our size of the list by the half size every time, and we will get the median answer in log n time. Okay, so let me open your a second. Karthik in. Where is branding? Okay, so find rotation.
No, this is fine rotation. This is the name. This is the previous one.
We are not getting any.
Can I share my screen? It's okay.
You are not writing on the here. Replit.
No, yeah, replit only. I've written.
That should be come here. One second. Problem 2. Yeah, this is your code.
Yes.
So find median. Okay, so you are doing with the same function. Okay.
Yeah, same. I'm just whatever we discussed. I did First is the first case, length 1,
Haha.
average. I took A and B, and then length 2, average of last element of A, and then
Hmm. So len of A is equal to 1. No, why? Okay, this is base case. Okay. So len of A equal to 1, then you are returning 0, 0 by 2. Okay, fine. If len of B equal to 2, then you are calculating this. This is not correct. That means we have two elements in the each B list. Okay.
because
A-
all are having same, right? Both the list
No,
are having
no, you
same.
cannot figure out this A1. So that means the second element will always come at the that second position. This is not correct.
I don't understand that because two element means this is sorted, right?
1 second. Sorted, but what situation we may have like this? Suppose we have one list 1 comma 1, okay, and we have another list like 3 comma 4, like this, okay. So in this manner, what you are taking, you are looking this element, okay, and you are looking this element. So 1 1 3 4. So in that way we are getting correct,
Yes.
okay. But there is a chance. One second.
No, always because this is two, right? Even. So always the middle element average, right? If we merge. So sorted, it is average. That is what we discussed also. I think we all agree that. Yeah.
1 second.
Still, there will be a problem.
Mhm. So in this case, if you see, so what you are doing, suppose we are getting this list. This is also sorted,
Mm. Mm,
okay,
mm, mm,
and you are taking this 4 and this
mm.
here. But what we should get? So 1 2 3 4. We should get this 2 3.
The answer is 5, right?
No, that is not always correct.
Okay.
Suppose this is again 2,
And
then what
7 or
happens?
something like that.
So it become a wrong.
Yeah.
So just figure out that what is the max of this and min of this.
Okay, that is better. Right.
Then you will get the correct. So you have
No,
to
it's showing some other error. Maybe this is
so that
okay.
we will check further. Okay, so no problem. Have you updated?
Yeah, I
Or
can update. I can update.
yeah, just update the code.
Yeah, I updated.
Max of no, not in this manner. Max of first element of the both list. That
Okay.
means A0 and B0, A0 comma B0, and that other side B1 and A1. Okay. Now move to the next part. So this is the if condition, elif condition, else part. Okay, else we are moving to this. Okay, fine. Now what you are doing, you are just checking that if the length of A is even, then you are looking for this middle.
I'm checking the middle. This is for the
Middle
middle case. Even
middle
middle case.
case. Okay, but you are only using this even and odd case things for middle case condition.
Mm, mm, mm.
Hmm. Okay, but we should also use the condition for the remaining part. Otherwise, we will get the different size.
That one else if I have else if, right?
No, where you are no. So here you are checking this size is even, and if size is odd, okay,
Yes.
and you are using this information here. But in the LF part, you are not maintaining these things, even and odd things. What will happen actually if size is even, then your list size will become different for the both list.
Hmm.
Okay, so just take some parameter for the mid A and mid B, and okay, and set that parameter based on this condition and use that parameter everywhere.
Okay. Okay. I'll try then.
Okay, so that thing, that one update is required because these things we have to maintain for the each call also, because in each recursive call our list
Mm-hmm.
size should remain same.
Yeah. Yeah. True. I need to capture that, right.
Hmm.
Okay.
So that one update is there, and otherwise, yeah, this middle element you have. So there's no need to check two times like this. Okay, so after setting the correct mid parameter, you can only check one time. After that, just take this condition. So this is middle element is greater than this. So then find median. Yeah. So first part of the first list and second part of the len of B. Second part of the second list. Yeah, this is fine. Call is fine. And if this condition is true, then second part of the first list and the first part of the yeah. Call is fine. Only just set this middle correctly and use the
Oh,
middle mid parameters. Okay,
okay. No.
then it will work. But one things is here. You are writing this binary search code and you are using this slicing. Okay,
Mm-hmm.
then you will not get the efficient code of log n complexity.
Because of the slicing, right, right, right.
So because of that, I have written the code with the parameters, not slicing. Okay, if you are finding the solution for the log n time, then do not use slicing.
Okay, okay,
Okay,
okay,
write the code without slicing.
okay,
Same for the any binary search problem.
okay.
Okay, so these changes are required, and after that, your code is fine.
Okay, sir. Thank you.
So one third problem is also on the similar line. Okay, so just try to solve that. Otherwise, we have 10th week free after the
Oh,
quiz. Okay, so in that week we will just discuss with the week 9
is
problems.
there any possible extension for the submission of week 8, 1 or 2 days, something like this?
I think no for week 8, because week 8 or week 7 is already extended due to quiz 1.
No, week 7, yes,
And
but
I think week 6 and week 7 extended maybe.
no,
But I
no.
am not sure about the week 8 will not extend, I think.
Uh-huh, uh-huh.
Yeah, week 9 may be extended, but yeah, after that week 10 we don't have the content, so that will be also free.
Okay.
Okay, so just
Oh,
try third problems. Okay, and if not, that is also tricky. Okay, but still try. Otherwise, we will cover in the next.
okay, sir. Thank you. Thank you.
Okay, thanks.
Thank you. Have a nice evening. Thank you. Bye.
Yeah, good night.
Good night.